Oh, don't do it.
Things we don't need to experience again. Headgear. Renting movies from the store, running with a CD player, and having one way to buy it all. So CarMax gives you options. You can buy on the lot, online, or any combination between. The way it should be. CarMax.
I missed you so much. I see it's back at the Cadiz. All because I saw Prince always a dollar. And McDonald's one too.
Phone it into 1-800-Farmers and you can get all sorts of home policy perks like the claim swing discount. For 3 years without a claim, get a discount. Just like phoning it in. Just phone it in.
Yeah, just phone it in and save money for being claim free.
Even if I switch to Farmers today?
Yep, 3 years claim free with any home insurance.
I'm phoning it in and saving money for literally doing nothing.
Get your policy perks by calling 1-800-Farmers. Go ahead, phone it in.
Phone it in right now.
We are farmers.
It's time for some straight talk. You've got work to do, so you order a latte with a side of free internet. Problem is, everyone's sucking up the free Wi-Fi faster than a mocha chocolate double strap on ice. So be your own hotspot. Now with Straight Talk Wireless, get 10 gigs of hotspot data included in our ultimate unlimited plan. Just $55 a month on America's largest and most dependable networks. So go ahead and try it today. You don't have to find a hotspot. You are the hotspot. Straight Talk Wireless available at Walmart.
Hey, you want to get out of here? We've got you. During Expedia Travel Week, save 20% or more on thousands of hotels. Just book between June 8th and 12th to plan your escape with Expedia. Expedia. It matters who you travel with.
All right. So today we're gonna discuss forecasting. So it's week 5. Hopefully everybody's doing well. Um, Make sure to get to your case study is in, and all your work. If you have anything missing, make sure you get that in. All right. So today we're going to discuss forecasting, as I mentioned earlier. Forecasting is really a major part of operations because it helps identify kind of what production level do we need to be at, right? We need to have an understanding of what's the anticipated demand uh, for the supply that we need to, have on hand, okay? And so companies spend a lot of money, do a lot of research, apply a lot of statistical analysis and different techniques in which they can, to the best of their ability, predict what they think the demand will be. All right. And so this is what forecasting is about. There's different ways to do it. And, the big companies, for the most part, as they have been doing business for a while, they kind of get a feel for what the demand is going to be, based on, a lot of different things. All right. It could be the season, so the time of year. It could be, based on some financial, catalyst. It could be based on a number of things. But at the end of the day, as a excuse me, operations manager, I certainly want to know to what level do I need to have some, um, inventory ready to go, right? And I don't want inventory just sitting there because I forecasted poorly, right? This is where you get surplus. Surplus isn't a good thing if you're talking about holding inventory, and you're probably gonna have to sell that as a loss or at least at a discount, right? And so forecasting is one of those things where it's imperative that you have a good grasp of forecasting and what forecasting is and why um, companies would want to make sure that forecasting is done properly. Okay. Um, so forecasting for decision making, right? So you have operations output, right? And really, as it says here, forecasting, we want to know what the demand will be, right? That's what we're really thinking about. Like, what do we propose, or assume, or estimate the demand will be, right? Right. Also, in the planning phase, what do we think the demand should be? And so, of course, there's a difference, right? What we think it will be and what we think it should be is the delta, right? In between there, which is the demand, okay? Which may differ from sales, okay? Just because there's demand out there doesn't mean that there's actually sales that are going to result in that, right? Again, you have, a scenario where, yes, I have a lot of demand and people are asking for something, doesn't necessarily mean they're going to buy it. Okay. It doesn't mean that they're going to commit. The price may be out of their, range. It may not be the right time for them. It may not be exactly, what they wanted, the specifications as to what they're looking for. And so, although they may want the product, it doesn't necessarily fit their criteria or whatever other criteria they have. And so, with that, you pretty much get the difference between demand and sales. Okay, and so make sure you keep that in mind because you can definitely have high demand and um, little sales or small sales, or the sales and demand won't really match. And what we're really trying to do is make sure that we match up the demand and the sales. Okay, we have a certain demand, we build this to we build or produce to that demand, and then we with the hope that our forecasting was correct or appropriate or at least very close, and we have sales that reflect our our forecasting. Okay. So a lot of times companies may under forecast, right? They may know what the demand is, right? But then again, they may plan and not make as many as they think you know the demand will be, right? And so hence you run into issues where, especially during the holidays, where there's not a inventory of a certain item, right? For hot toys on the market, and you want to get it for your kids or whoever, a hot item, and you can't get it because there's not enough inventory, right? More than likely, the companies are erring on the side of caution, and not wanting to hold on to inventory with assuming that it was going to sell, right? So that can protect the company in one way, but in another way, the company is losing out on market share, because if I can't find it via your organization, and hopefully it's a rare, unique, can't be obtained only from it can only be obtained from me type item, right? If that's the case, then that's great. But in very rare instances, is that the case? Okay. Um, so yes, I may want some kind of a pair of shoes or something like that, right? But it's not. There's no inventory for it. So guess what? I'll find it someplace else. Excuse me. Either in a aftermarket scenario, or I'll take a substitute. Right? I'll take a substitute that will meet my needs and my desires. May not be exactly what I'm looking for, but it'll do the job, right? So you lose out on market share, and so that means that there's another company or another business who's selling items and making money, making sales, right? And so you really want to be as close as you can to forecasting properly. Okay, forecasting is used in the organization throughout. Okay, marketing, HR, fine. It doesn't matter. Everybody forecasts to some degree, right? HR forecasting how many people we're gonna need for particular, job or growth. Finances forecasting for how much money we're gonna need to buy maybe oil or raw materials and that kind of thing. And when we talk about options and crops and commodities, I should say, really, right? So we need to be able to allocate funds. And so the funds that we allocate really are based on our forecasting and deciding whether or not this is going to go in a certain direction. Okay. Um, Forecasts are necessary for operation decisions, right? As I said this already, right? Capacity planning, inventory management, scheduling. You have to have forecasting, and so that you kind of have a plan or at least a guide as to what your goal is. All right. And that's really what we're talking about here, right? So if I forecast for a certain amount, that helps me figure out, okay, how much of it, how much capacity am I going to need, right? How much, space am I going to need to hold? How much, how many, what kind of design am I looking at? Hey, Debbie, how you doing? How you doing today? You good?
Thank you.
You good?
Yes.
You got any questions before I continue? No questions? Can you hear me?
Yes.
Okay,
Yes, I can.
no problem. You have any questions?
No.
Okay. All right. Just if you do, just stop me, or comments, just stop me and comment. Okay.
All right.
Okay.
Thank you.
No problem. All right. So some of the methods that we use, right, is qualitative forecasting methods, and then there's also quantitative forecasting methods, right? And so qualitative is really based on kind of more of a feel, right? It's categorical. It's not numerical in nature like quantitative is. So it's not hard and fast. It's more or less having an understanding of, okay, what do I think is going to be, right? And it could be based on, a number of different other models, right? It could be based on a naive forecast, which is basically, what happened last year. Okay, so simple as that. Or, hey, we know that in 6 months, there's a winter storm coming or something like that. Okay, so we're gonna forecast based on that. Something like oranges and crops and those kind of things, right? They forecast early. When airlines are buying fuel, they buy fuel a year in advance, right? Because they are forecasting the amount of travel that they think they'll be doing. right? And also taking into consideration the prices of the oil. And so if the fuel is it's just better to lock it in because you're not sure if the price is going to go up next year, right? So you don't want to be buying it on the spot. Um, and so, it's just better to pay for it now and just make it easy. That way I know I'm locked in and I can use that fixed cost in my forecasting model because I know okay, exactly how much oil fuel I bought, how much I'm getting. And so that number is not moving around. It's not an adjustable variable number, right? Just kind of, I got it as variable, but I got it locked down because I know exactly how much I bought, right? So you can do, Delphi technique, market surveys, like I said, informed judgment. These are all kind of ways in which you do qualitative research, where you actually kind of get input from people, but more in sometimes in a conversation, but more or less through surveys. But the surveys will be, what do you think you will, what do you think you're going to have a high consumption of water, right? Do you think that, how much electricity do you think you're going to use? A little bit, a lot, a whole lot, right? Are you going to be using your air conditioner this summer, right? Do you work, right? And those questions will help us decide and figure out, okay, how much do we anticipate people are going to be using electricity during the day, right? This is how, when the utilities companies, when they forecast for how much energy someone or a household uses, it really is based off of the fact that the assumption that people go to work. And so that during the day, no one's really at the house. People go to work, kids go to school. And so they're not going to be using a whole lot of energy and a lot of electricity. So the prices are lower, right? The cost is lower per kilowatt, right? But once you get to those special that special time frame between 4 p.m. and 9 p.m., that's the highest rate because they know that people are home and people are going to be doing the things they need to do: washing clothes, washing dishes, watching TV, surfing the internet, making dinner. They're doing all these things. So their forecasting for that particular time frame is going to increase, all right? And also the price is going to increase along with it because then they can take advantage of their increases that they know are coming, all right? So the forecasting that they're doing helps them do that, right? Helps them figure out, okay, it's summertime, people will be using the AC, or you know what, it's really not that hot of a summer, right? We are into was June 2nd now, and it's still cold at night. All right. It's still not to the point where people are turning their air conditioning on just yet. And so they may or may not have, forecasted that. More than likely they did. They probably, took their time and figured out, okay, this is what, it's going to be, and this is what the temperature is going to be like. So we don't anticipate people actually using the air conditioner probably to like mid to late June, if not into July. All right. And so these are all things more like they might even turn on their heat, depending on how cold they are. Okay. So you never know. Right. So that's one type of forecasting when you talk about qualitative forecasting. You have time series forecasting. And like it says, it's based on time. Okay. It's based on time. Either, a certain period of time, like the season, right, is based on maybe trend, right? Something is really hot right now. And it's like, okay, time is of the essence. Excuse me. And so we want to make sure that we are going with the trend, right? We don't want to go against the trend. If the trend is that, everybody is eating outside and offering outdoor dining, and we aren't doing the same thing, we're going to lose out on business more than likely, right? One, because people want to eat outside. Two, are we going to, pretty much exceed our capacity as far as indoors, right? Yes, are there some added costs and expenses to, having an outdoor venue? Sure, but that also the revenue that you're going to make from having an outdoor venue is going to more than cover your expenses for uh, the venue, and you're going to make a profit. So those are the things you look at, but you have to be ready to move with the trend. And really, when you see trends, it's really about responsiveness. okay? Because as quickly as the trend comes, this as quickly as it could go, all right? 1 week, something's real hot, and then you plan around it, and it's taking you a whole week just to get it together. And then by the time you get ready to go, boom, the trend is done. It's over. You've lost the momentum, and guess what? Now you're stuck with something that you can't use. So you got to be cognizant of the trend, right? Cycle, okay. Again, looking at the business cycle and kind of figuring out, okay, what's our business cycle, right? So let's go back to cars and the automobile industry, right? Every October, for car manufacturers, new models come out. Okay, so for dealerships, for them, September and October are months that they're really trying to sell all the old inventory they have on their lot because they have to make room for new inventory, right? And so they have to forecast, really, really well in order to not waste money, in order to make sure, like, hey, we don't have a surplus of inventory. This is why you don't necessarily, when you go to a car dealership, you don't necessarily see cars in a bunch of colors, okay? Because forecasting tells me, like, most times 8 out of 10 people do not want a yellow car, okay? Nine out of 10 people don't want a pink car. They want a black car, a white car, a silver car, maybe a red and maroon car, a nice blue car, maybe, right? But people are very, generic with their colors in their cars because most of us kind of like colors, but we don't want to stand out. We don't want to be like, oh my goodness, that color is like hideous, right? So that's why you don't see those car colors on the lots. Not to say they're not available, because we know they're available. It's just that you have to go in and ask for it, right? As a custom order, right? But the manufacturers use this as a forecasting means to say, okay, we're gonna make 5 yellow cars. Okay, we're gonna make 5 yellow ones in this particular model, and that's it. Anybody wants a yellow, whatever other model, cool, they can get it. But there's some cars where it's just like, nope, we're not even thinking about it. These are colors we're making, and that's that, and we don't want to hear about it, right? But understanding the cycle of the business, right? October, new cars, old inventory out, new inventory in, more than likely for holidays and for New Year's. People are buying cars. When tax season comes around, people are buying cars, right? So you have to understand the cycle of the business and also the internal cycle as far as, okay, when parts are available, when manpower is going to be at the highest or the lowest internally, and understand, okay, how does that work for scheduling? How does that work for ramping up and ramping down and that kind of thing, right? And then you have your error, right? So random or irregular component. Again, something to where you are producing something that is not necessarily it's just a one-off, right? It's just a one-off, but you're trying to, at the same time, figure out how to forecast that. Okay, how do I forecast something that is not, that doesn't occur all the time? We could take COVID for instance, all right? How do I forecast what's going to happen in COVID, because we've never actually been through something like this, not at least in the last 100 years, was the last time we had a pandemic of this level, right? And so forecasting and people understanding, like, okay, well, come June 15th, you don't have to wear masks anymore, all right? Come July, everything's going to open back up. People will be able to travel to different countries again. Come August, we're going to open the schools back up, right? And stuff like that. People will be going back to in-class learning and stuff like that. So it may or may not, right? But, when you're talking about time, and trying to figure out, okay, over a certain period of time, how can I forecast what's going to happen, all right? And that's really what I'm looking at, because most things happen based on a time series, okay? Like I said, from October to December, that's the holiday season. And so a lot of times people are buying a lot of things. They're, making sure they have it low inventory. They're getting ready for Christmas. And then the new year comes around, you have birthday, you have all these things that we're trying to forecast, but they're really based on time and season, all right? All right. The next technique is moving average, right? And so the moving average is something that they use a lot in the stock market, okay? You have your simple moving average and you have your weighted moving average, right? And all it is that we take the average and we look at it as it moves over a certain period of time. Okay. So if we have a simple moving average, you just say, hey, every 12 hours, we're going to take the average of something, right? We're going to take the average of the stock price, right? And then every 12 hours, we can see how it's moving, all right? And that gives us an idea of, okay, this first 12, second 12, third 12, what's it going to look like in the fourth 12, all right? What can we forecast to say, what's it going to look like in, 2 days, all right? Based on the simple moving average, all right? The weighted moving average is a little different. Same concept, except now we add weights to it, right? We give the criteria or the components a certain weight. So let's just say, for instance, I'm trying to forecast again a stock, all right? But at the same time, I may give it a weight of 2 because this stock is not a really hot stock. It's a low grade stock. A lot of people aren't buying it, but I'll give it a 2. This stock on this hand, on the other hand, though, is a 9 or a 10 because everybody wants it. It's a hot stock. So I'm going to give that more of a weight, make it heavier, and give it more importance and more value so that it reflects correctly in my forecasting. That way I know, hey, based on the way they're moving average, this is what it's going to look like. And it's going to look like this because we looked at each component and said, hey, this one deserves a 1, this one deserves a 2, this one deserves a 3, this one deserves a 4, right? It's sort of reflective of kind of like your GPA, right? A is equal to 4 points, B is equal to 3, C is equal to 2, and then D is equal to 1, and F, of course, is 0, right? It's weighted. It's not necessarily moving, right? But it's weighted, and it moves technically over the term of the 8 weeks, right? As you start to submit stuff, depending on the weight, your average will change, all right? And so as you start getting closer and closer to the end, right, the end of the 8 weeks, you'll notice that, hey, I had a 90 or an A average, but then I took a test and the test was worth 25%, and I got an 80 on it. My average is one down, right? And so now you can forecast what your grade is going to be. But then, okay, what I need to figure out is that what do I need to do on the next thing, right, based on its weight to get my average back up to 90 again, all right? So that's kind of how the weighted moving average works out. There's programs and software and things like that do this, but you may touch on this in statistics, maybe, depending on what it is. Definitely corp finance, you'll start looking at simple moving average and weighted moving average and production management for sure. All right, because all these averages, whether it's simple or moving or weighted, excuse me, all have their value and really play an important role in the forecasting of stuff. Okay. And so as an example of a moving average, all right, we got, period 1, the demand, and then we have the forecast, right? And so as you can see, if right here down here, they have the formula, right? Compute 3 period moving average for period 4, right? And all they're doing is really saying, hey, if we look at this actual F4, because we have 4 periods, okay? And what we're looking for is the demand here. So we add each of the actual demand periods divided by 3. That gives us the average of these 3, which is the forecast for week 4, okay? So we use our past data in order to create our future data, right? Our future forecast, all right? And so, but we use the moving average because we're looking at it from the standpoint of each period, right? Each time series. Again, 10, 18, 29. All right, the average was 19. So that will be the average, the moving or the forecast for the period 4. But then the actual demand for period 4, right, is 4 plus 29 plus 18. Okay. And so, 29 and 18 divided by 3. Okay. So you kind of get an idea of, how, the next forecast period is going to look. So, okay, well, if I look at this and just keep it, as a moving average, then I can say, with some level of confidence that I have a need or demand for 19 widgets or whatever the case may be. Okay. Now, if you look at the 19, you compare it to the different periods, you'll see that the only period that is really close to is this second period, right? But the thing is that we're looking for an average. Okay, we're not looking for it to be closer. So at the end of the day, once we're done with the year or whatever our reporting period is, it would all pan out. It'll all work out to where it's just fine, and it's going to be where it needs to be, and our average, our forecast, will be on point, and our forecast will be pretty close to the actual demand that's out there, right? And so the demand that is out there hopefully translates into the equivalent sales, right? Because you have demand doesn't mean you're going to have sales, right? Because a lot of people may want something, but that doesn't mean they're going to actually go out and buy it, right? They may tell you, hey, I want this, I want that, but doesn't mean they're going to spend the money on it because it may not be exactly what they want. It may be too expensive for them at the moment. It may be the third or fourth thing that on their list of things that they would like to get. So there's different things that go into it. But the hope is that we have the actual demand, we have the forecast, and that the forecast and demand translate into the equivalent sales, right? All right. So here's a nice little graph here. Not too complicated, but definitely not something that you want to look at all the time, right? But all it has is basically the demand or the averages as it goes, right? So this first one here is just the demand data, right? You can see based on the time period what the demand is at every point, boom, boom, boom. And then you have the 3-period moving average, right? Which we just did, right? So they took the 3 periods and then they graphed that, right? So this is how it looks when we graph the actual 3-period moving average, right? And then we did the 6, well, this dotted line here is the 6-period moving average, okay? A lot of times they come in different colors as they should, right? But they denoted the difference by making it a dotted line and that kind of thing. So you can see that for the most part, it's pretty consistent. It's pretty good, right? Because it's following kind of the same pattern, right? Up, then it drops down, then it drops down, then it goes up, then it drops down, then it goes up. So if you look at the demand data, it's pretty consistent with it, right? And so as you get more periods or more time series, right, you have a better chance of forecasting in a more appropriate way. Okay. So again, the more data you have when it comes to forecasting, the better, right? And the only way you're going to get more data is via time, right? Every period you have helps you forecast better for the next period. All right. So if I have 6 or 7 or whatever, this one is 14 periods. When I get to period 6 or 8, I'm halfway through the cycle. I have a pretty good idea of what the other periods are going to look like. But that's because I have all these periods and I'm coming to the end, right? As I start to exhaust the periods, right, and I start coming to the 14th period, I'm getting a better idea, and I'm getting closer to 100%, right, or the whole. I have a better idea of what the forecast is going to look like. And I probably, by the time I get to here, unless something happens, I pretty much have a good idea exactly what it's going to look like. All right. I know exactly what the demand is going to be. I'm pretty much sure I know how much I'm going to forecast for. And I probably have a good idea on the sales, right? But again, it's time, and then it starts all over again. All right. It starts all over again because every time period is different depending on what's going on in our society, right? Economically speaking, right? Financially speaking, you know social events and social phenomenons, right? Those kind of things, boycotts, just the Black Lives Matter movement, Corona, White Lives Matter. It don't matter, right? All those things have an impact on forecasting because if people aren't working, right, there's no money to spend. So why would I think there'd be a demand for certain things, right? Things that aren't necessities, more than likely that it's not going to be a demand. People weren't spending money on traveling, or spending money on the movies, or it just wasn't happening like that. But now that things are kind of get back to normal, the movie theaters are opening up, right? All the churches and schools, right? The demand for fuel is going to start go back up again because people are driving more again, right? The airline tickets are going to go up again. Hotel is going to go up again. Hotel rates are going to go up again. So everything's going to increase in price because people are getting back out into the world. But at the same time, people are back to making money, right? They're back to making money. And eventually we will get rid of like some things like benefits like unemployment benefits that have been kind of moving the economy a little to get people back into, working in their regular job, right? So exponential smoothing, again, is just another technique in forecasting, except that what it does is it takes the old average and uses a constant, right? So smoothing is more of a statistical type topic, and what we really trying to do is we're trying to find an average constant or average weight that can be applied to the whole process that can help us, build a predictive model that will be consistent no matter what, right? So when I talk about a constant, we're talking about something like, E equals MC squared, or, 2 pi r squared is, diameter of a circle or something like that, right? Those are all constants, all right? 2.14 is a pi, all constants. And those constants are there because I know for sure that's what it is. And based on that, I'm going to use that constant to help me kind of regulate this particular model, right? I know that this number will have a certain impact, and just based on the inputs I'm given, then I can kind of figure out the what's the output's going to be, right? And so this constant here is called an alpha, right? And you'll see an alpha when you take statistics, right? An alpha and basically is the significance level, right? At what point do we determine that something is important, right? When it comes to research and data and kind of that critical point of making a decision or not. All right. I'm not going to get too deep into it, just because it really is a statistical thing. And if you get into operations management, production management, you'll have more than enough time to really get into it and understand it. But you have to have a decent understanding of statistics and statistical techniques when it comes to getting the alpha, right? So alpha ranges between 0 and 1, but it's usually 0.1 or 0.2, right? And this is strictly for production and operations management, right? For research purposes, for a, if I'm a social scientist and I'm doing research, the alpha normally that's accepted universally is 0.05. Okay, 0.05 is the alpha for if I'm doing research social sciences. But if I'm doing, forecasting and doing exponential smoothing, then it's 0.01, 0.1 to 0.2. All right. All right. Simple exponential smoothing, same thing, except now we have more of a, kind of predetermined variables that are a little bit easier to attain, and we can build our model pretty well. Once we have our constant, it's just a matter of plug and play, all right? So we have F equals the forecast of demand, D is the actual demand, and T is the time period, right? And then the simple exponential smoothing, it doesn't, it just is. It doesn't take into account anything about season or the economy or anything. It's just straight up like, okay, what was the forecast? What's the actual demand? And what's the time period we're looking at? All right. Because the notion is that all these factors have already kind of been are inherently included in these things, right? If I'm looking at the forecast of demand, I probably forecasted for all the things that are going on. The actual demand is already a hard number. It's not going to change. And the time period definitely is not going to change, right? Unless I need to look at different time periods, right? But like I said, assume no trend, seasonality, or cycle. I'm just looking for a straight up, what you call it, forecast. Okay. Okay, here's an example here. All right. September forecast was 15, but September actual sales were 13, I think it says. Yeah, 13. Use alpha of 0.2. What is October forecast? Okay, so September forecast, all right, plus the alpha times the September actual September forecast, right? And so basically we're just following the formula we had before, right? So the forecast for September was 15. Our constant is 0.2. We have the actual from the forecast, right? So that gives us our delta of where we didn't exactly hit it on the mark, but we we're too far, right? And then we take that and subtract it from there, and that gives us what we are going to use as a forecast for October, okay? Because we could see that we forecast 15, but the sales were 13, right? And so maybe there's something we're missing. So guess what? We're more likely, maybe we'll go back to 15 again because it's 14.6. Or maybe we say, you know what? Let's just maybe do 14. Maybe we won't round up. Maybe we'll round down. It all depends on, what it is and what's going on in the company, right? But this is pretty much straightforward, real easy, smoothing example. All right. Oops. Excuse me. All right. Here's another time series. I think we looked at the same one before. Again, the demand. This is the forecast, I think. Yeah, and this is the actual. Okay. So on the demand, on the forecast, we have a 0.3. On the actual, we have a 0.1, right? And so we'll go in and kind of, as we move along, right, you'll see that this dotted line here goes to 0.1. This one stays to 0.3, right? So we have more certainty here about what's going on or what's going to happen, right? So our constant doesn't necessarily need to be so high, right? It'd be a little bit lower because we have a pretty good idea that what we forecasted is pretty close to what the actual demand is going to be, right? But again, it's over time. So when we get down this side, right? We're here at the six time period, but now we're here at the 14, almost 13 time period or 14 time period, and it's 0.1, right? So you see how we reduce the alpha in order to accommodate the time. That's really what we're doing. Okay. Okay. So let me see. No. Okay. All right. So, looking at the forecast, and like I said before, there's a lot of things that go into the forecasting and its accuracy, right? There's a lot of, outliers. And again, when you get into statistics, you'll have, if you haven't already, you should be familiar with outliers, right? And outliers are those things that fall out of the range of the average. Okay. They just, don't meet the average. They're not average. And so, you have to account for outliers, and outliers, averages are very sensitive to outliers. Okay. And when we say outliers, let's just say, for instance, I was going to take the height of the class, the average height of the class. Okay. And I take the average height of the class, and then the average height of the class is, 5'6" or something, 5'7". And then somebody comes in who's 6'5", okay, and now I have to include them in the average of the class, right? They're gonna throw the average off, right? Because nobody else is 6'5" except for them, and so that person is an outlier. And so there's a couple different ways you can deal with that. You can just take it out, or you can keep it and annotate the fact that, hey, there was an outlier, but we're gonna go ahead and keep it, and this is why the average looks the way it looks. Okay. So the next thing is determine when the forecast demand is no longer tracking actual demand, right? And so you have to recognize, when is my model not actually doing well? Okay, when is my model no longer, working to where I can actually, see what the actual demand is going to be, or what the actual demand is, right? Have to go back in and figure out, okay, is my forecasting method really, predicting, or at least doing a good job of predicting what the actual demand is going to be, right? And you have to determine the parameter values, right, that provide the forecast with the least error. Okay. When we talk about the parameter values, you're talking about the criteria or the specifications, right, of your forecasting models, right? What things are we going to look at to evaluate the forecast, right? And so when I say that, we're talking about like something like weather. Is that an important parameter? And when we talk about parameters, we really talk about the population of something, but we'll stay out of the stats for right now. But is weather something that I need to take into consideration for my forecasting model? Is the presidency something I need to take into consideration, right? That parameter important in the sense of, is it going to impact my forecasting, right? So you have to determine the parameter value that provide the forecast with the least error. What criteria, what things am I going to look at is going to help me get as close as possible as I can to my forecasting. All right. Different ways to do this, right? Measure the forecasting error, accuracy, excuse me. You have your cumulative sum of forecast error, okay? Mean square error, which is really more of a common way in which to, get accuracy and figure out what the delta is, right? Mean absolute deviation, mean absolute percentage, and tracking signals, all right? All these methods, a lot of them are statistical in nature, but these are the formulas that are associated with all these forecasting accuracy formulas, okay? And so pretty straightforward, not too much, too much things that going on with it. You do have to understand a little bit of math. And then you see here, this E, the E is a constant. If you look at your calculator, any calculator for that matter, even on your phone, you'll see this E, right? And basically this E is the E equals mc squared, the speed of light, okay? So 2.78, something like that, times 10 to the third or something. I can't remember what it is. It's something ridiculous, right? But if you click the E button on your calculator, it'll give you a number, right? And so that's the constant. And so you see the E is in every one of these formulas, right? The absolute value of E to the T, E squared to the T, E squared to the T. And the T is just a representative of each factor that you're looking at, okay? Or each period, or the time, I should say, that you're looking at, okay? So again, I'm not doing a deep dive on this because a lot of this is a lot of statistics. And so it's not, you're not going to necessarily be dealing with it right away. And then when you are, you really just need to understand the concept behind it, because the software and, the computer does all this stuff for you. You just plug in the inputs, and it spits out what you need. It gives you exactly, hey, this is what we're going to do. It's the forecast. So all the algorithms, all the, the programs do all this stuff for you, but you need to understand which one's going to make the most sense to use, okay, and why, right? Again, it's based on what kind of forecast you're trying to do, the time period, you're doing it in, right? Are we looking at, 6 months, 12 months? Are we looking at, a week, a day? Do we need it right now? Those type of things are what we're thinking about. And then also, were there any outliers or any irregular events that occurred that would have caused some kind of deviation or some kind of, tick or change in the accuracy of the forecast, right? So we have to account for that also. All right. Oops, excuse me. Some advanced time series forecasting. Again, not going to get too much into the mathematical models, because it's a whole nother level of, it's another class altogether on its own. When we talk about forecasting, right? Just understand that there are different ways in which to forecast. And so depending again on what it is you're looking for, you're going to be using a certain type of forecasting method. The stock market uses this, on a regular basis. This is just part of the technical analysis you would do if you're buying stocks and that kind of thing. You start reading the charts and the graphs. And I'm not sure if you understand stocks or not. You know how to trade.
Not really.
Not really. You don't buy
Yeah.
stock?
Actually wanted to buy recently,
Uh-huh.
but then I was told that I'm going to need social security number, which I
Yeah.
don't have yet.
Okay.
So I can for now, but I have like an idea.
Okay. All right. Yeah, you're more likely going, I think it's social security number. I don't-
Yes.
do you? Yeah. Interesting. Okay. Um, but there definitely when it comes to the stock market and most companies, they're going to use a very sophisticated forecasting method because they want to make sure they get as accurate as possible because just forecasting, by 1% or 2% that's off, that's millions of dollars, right? You have to think about, hey, we're forecasting this and we're hoping the demand is there and the sales show it. But if it doesn't sell, guess what? We got to sell at a discount, right? We got to get rid of it, right? We can't let it sit on the shelf. There's very few items that you can let just sit on the shelf that, aren't going to go bad or become obsolete, right? So computers is one of them. There's always new computers coming, right? New models every, 6 months, a year, whatever, right? Because after a while, the computers become obsolete, right? The operating systems are no longer, relevant. The capacity and the speed at which they're moving is super slow, right? Just think about when we first got cellular phones, right? All you could do was open the phone, dial your number, you could talk. That's it. Now you could live on your phone, right? You don't need anything else. As long as you have your phone, you're good, right? It's because the capacity is grown, right? The storage, the memory, the speed. But if someone was trying to sell you a old flip phone, you probably like, well, what am I going to do with that? I can call, but that's all I can do. I can't even text anybody. I have to keep punching the number till I get to the letters I want, right? Not not cool, right? So you don't want to do that. But again, if you don't forecast correctly as an organization and you have too much surplus, you're gonna have to discount it, right? To get rid of it, right? Unless there's some person out there who wants it, right? Who actually needs it, and then those people are in that business. But for the most part, and they're still gonna sell a discount because more likely, if you have a surplus, other people have surpluses too, and they can get it from someplace else, which is one of the issues when it comes to forecasting. All right, causal forecasting message, right? Method. And so when we say causal forecasting method, we're talking about just cause and effect, right? You're using data that's gonna really show a relationship between the two, what we call bivariate, okay? And so basically, if I say I studying 5 hours is gonna get you an A in the class, all right? That's a cause and effect. All right. If I study 5 hours, I get an A. If I study 4 hours, I get a B. If I study 3 hours, I get a C. We know that's not true because if it was, then everybody have A's because everybody would study 5 hours and then call it a day. Right. So you have these cause and effect models. And what you're looking at is how do I forecast, what's going to happen based on cause and effect. And they use this type of modeling, right, in weather. Okay. Meteorologists use this type of modeling. They use it in the stock market too, but it's a little different. But this modeling, hurricanes, all right, natural disasters, a lot of times use cause and effect because they look at, okay, something just happened, right, or something's going to happen. There's going to be certain conditions, and it's going to create this effect, right? And so we're forecasting hurricane category 2, category 3. Everybody's always curious as to, okay, how do they know which direction is going to go in, right? It's because they're looking at the criteria, right? What are the parameters? What are the characteristics of the components of our situation, right? And then we can figure, okay, there's high winds, there's okay, like for instance, do you know why California never gets hurricanes? No idea.
No.
Okay.
Yeah.
Is that you? Is that somebody trying to answer, or is that the TV? Huh? I can't hear you.
Oh, sorry, it's another stuff entirely. Sorry,
Okay, okay.
sorry, background noise.
I thought there's someone in the back, like they want to answer.
Nothing.
So the reason that we don't get hurricanes in California because the water's too cold. Okay, the water's too cold. The temperature's not, it's not warm enough for the conditions to be set to have a hurricane. That's why you'll never have a hurricane in California. You might have a tsunami, but that's not based on weather conditions. The tsunami is really based on what's going on in the earth, right? The movements of the tectonic plates and that kind of thing, right? Shifting of the earth, and that creates these waves, and that's how tsunami goes. But hurricanes are different. Hurricanes are based on, the temperature of the water, the air, the wind, those kind of things, and the meeting of the warm water where the cold water meets, and they kind of like have a party, and they get together and have a fight, and they create this kind of lots of precipitation, and we're gonna go party. We're gonna ask wind to join us, and we're gonna get out of here. We're gonna go find ourselves somewhere to go have fun, and that's how hurricanes are. But you will never have a hurricane on the West Coast. It was California anyway, because the water's too cold. Now, the Pacific Ocean is too cold, right? But you see in the Atlantic Ocean and the Gulf of Mexico, they always have hurricanes, right? Because the water is warm, right? And the conditions are perfect for that, right? And so this is how meteorologists use the information of that and use and kind of can set up causal forecasting models, right? And so when you have a causal forecasting model, one of the main ways in which to, kind of build a model is called a regression model, okay? Right? And that's your most common model, right? And so all it is y hat, which is the outcome, equals a, right, which is your variable, whatever it is, plus bx, right, and b is your slope, and x is your variable, excuse me, and a is your constant, x is your variable, and then b is your slope. Okay, so a is that constant that you have. Okay, that is like, okay, this is my base. It's, it could be, 100 units or 100 degrees or whatever. The slope is the rise of a run, okay? And basically the slope tells me as one component is doing one thing, the other component is acting in a second way, right? In another way, right? So if I were like, again, go back to the studying and the grade, okay? If I study 5 hours, my grade goes up, right? So study 5 hours, grade goes up. The more I study, the higher my grade goes, right? So that's what we call positively correlated, or a positive correlation, right? Sometimes you'll have a negative correlation, right? And so, yes, I study more, but my grade is going down, right? Because I have other things going on, maybe, or maybe I'm not studying efficiently, right? But I have a model here that I can build in which it can tell me, like, hey, for any inputs that I have, right, I can figure out what the outcome's going to be. Okay. So again, if I have the constant of, 5 hours, and my outcome is an A, right? I want the outcome to be an A. I have a constant of 5, and I don't know what the slope is, which I need to figure out. I'll figure the slope out, and then whatever time frame I put in here, whatever X I put in here, I can always figure out what the outcome's going to be. This is how they kind of not kind of, this is how they do predict sales. Okay, if I have 100,000 units, and for every 100,000 units, the price goes in a certain direction, right? And then let's just say the price is X. That's going to give me this outcome, which is my total income. Okay. Again, more statistical stuff, right? So production management, operations management is a lot of stats, right? You have to understand statistics, quality control, regression models, correlation. There's a lot of stuff. ANOVAs. There's a lot of stats in what your chi-square. There's a lot of stats in this stuff. So just know that this is basically the formula for a line. Okay, this is a linear regression. It's just a formula for a line, but it's also our predictive model. Okay, I know what the outcome would be because I have a constant, I have my slope, the rise and the run, all right? And I'm going to get my X, right? And any X I put in will give me my outcome because I have all these two other components that I've determined are fixed, okay? I know it's a lot. And you're like, what do you say, Dr. Case? Which is fine. No worries. I understand, okay? So no worry about it, all right? Simulation models is another one where we use that a lot because simulation helps us create a scenario and see what could possibly happen without suffering the consequences. All right. And so think of it as let's just say you have a new pilot, right? Somebody's learning how to fly. Are you going to put them in the plane the first day and tell them, hey, let's go see how you do? No. All right. Exactly. You're going to crash. You're going to die. All right. So you can only do that once. All right. So what you want to do is build a simulator. You put them in a simulator, same situation. It simulates the environment, the situation as best it can, right? And they go through the simulation. And so the simulation gives you an opportunity to make mistakes without suffering the consequences of death. Okay. So I can go to simulation and just keep doing it. Hence the simulations, the genesis of video games. Okay, that's kind of where video games came from. Video games was actually a military thing. All right, simulation models, those are all there was a military thing, it was a government thing. And then they figured out, oh, people like playing games. People like this stuff, all right? And they turn into video games. And so now, we use video games, but all video games are simulations. They're all simulation models because we are going to a scenario, all right? And you can keep practicing, You're going to get better and better till you're really good at the scenario, all right? And then you may die 10, 15 times, but you're not actually dying, all right? But you're learning about how to navigate through that situation, right? Only through simulation. So, pretty good stuff. Econometrics, really, we're looking at some of the economic features of a particular scenario situation and using that in our model. Okay, elasticity, inelasticity, poverty level, not poverty level, but wage levels and that kind of thing. Like how's the the interest rate, those things, right? How do we use those things to kind of figure out, okay, how do we forecast GDP, GNP, those things, right? Those are all econometrics. Yeah, I can that word. Input output, same thing. We're looking at, hey, if we put this in, what's going to be the output, right? Pretty straightforward and simple. Nothing crazy, right? So an example of a causal model, okay? As you can tell here, this is all the data, okay? It's all the data. And then here is what we have, the intercept and the slope. So the intercept is the constant, right? And then we have the slope, which is 2.39, right? And so we know that as x does one thing, y is going to do another thing. So it's 2.39. For every incremental change in x, y is going to change 2.39 increments, okay? And so all we do is we put the intercept here, that number 38.23, we put it here. We take the slope, we put it here, and then t is going to stay empty because that's our variable, which we don't know yet. But when we do get the t, all we do is put it in the formula and we calculate it, and then that'll give us our outcome yt. Okay, page 4. There you go. So DT, actual sales in years, forecasted sales, and the median family income. So what we're looking for here, right, is our outcome right here. So we're going to put actual sales, forecasted model, forecasted sales, and then add median family income, right? And that'll give us our Y, right? Boom. Okay. So forecast for period 7 is 128.34. And you can see how they set it up. And it's 1, 2, 3, 4, 5, 6, 7. Okay. So they're trying to find this particular sales, actual sales. All right. So that will go right there. Boom. All right, right there, excuse me. All right. All right. So we should be good to go. Again, you should have picked this up in algebra too, because you do, linear regression or the equation for a line, that same thing. But if you didn't pick it up, you definitely will pick it up in statistics and would, you'll do regression. So I don't know when you guys take stats or, but you should have taken it already prior to this. No?
No.
Okay. Yeah, probably a good idea that you take stats before. But again, we're not getting too heavy into it, so you'd have to really be heavy into it. Understand? Okay. So selecting the method, right? And I said before, oops, when you're really looking at selecting the method, it's really about what's going on not only in the company but externally, right? What's going on with the economy? What's going on with interest rates? What's going on with financing? Can I get money? What are we doing as far as like long-term planning, short-term planning? Are we ramping up for something else? Are we going to kind of minimize, or have a lower forecasting amount because maybe we last quarter we had a surplus, right? Maybe we made too much last quarter, and like, okay, we made 500 last quarter, we only sold 300. It means we have 200 left. Let's just make 100 this quarter, right? And see if we can average out and balance out and get all this stuff out of inventory. Okay, that's what we're really trying to do. You want to look at the data, right? Is the data available? That's going to give you, a good forecast, right? It's going to really match up with the demand out there, right? And so the quantity of the data is important, but the quality of the data is even more important. Okay, having a bunch of data is great, but if the data is trash, it's not. It's going to result in an output that's trash. Okay, so what you want is if you can get a high volume of quality data, that's the most optimal situation. How often does that happen? Not very often. Okay. More often than not, you have a lot of data with what we call noise, right? Stuff in there that is not even relevant. Like, I don't care if you brush your teeth at 6 a.m. in the morning. That doesn't matter to me. All right. If I'm trying to forecast, how much toothpaste you're going to use, that's not an important aspect. Right. I don't care about what time you brush your teeth. I just care about if you brush your teeth or not. Okay. So I can eliminate that particular piece of data. Right. I don't need to know your shoe size. I don't need to know what you wear. I don't need to know if you wear glasses. Maybe I do need to wear, if you wear braces, all right, or something like that, or if you have dentures or something like that. That's an important piece of data that might make sense, right? But data, when it comes to data availability, it's all about the quality. Now, sometimes you have a very small amount of data, and it won't be sufficient enough to make a good forecast. But at the same time, if it's high quality data, then you probably want to just roll with it. Okay. And then your data pattern, right? Do I have stable data coming in as far as like on a regular basis? Okay. Is it more of a cyclical or is it unstable? Like, sometimes I can get it, sometimes I don't. Sometimes we get, a bunch of it. Sometimes we just get little. Sometimes I don't get any, right? You have to kind of figure out, okay, where is our data pattern at, right? And if it's something that's level and it's stable, then we can always count on it to be sure that, okay, the data is consistently this way. Okay. If you can get some consistency in the data, that's great. That's what you want. You want the data to be consistent, right? Over a certain period of time, because then that tells you, okay, well, I know last year it did this. It should do the same thing this year because nothing has changed. Okay. If nothing has changed from year to year, then I should be able to use the data pattern that I have from last year to forecast for the upcoming year. Right. And so that's how you kind of get the whole thing where, people can forecast out, exactly what's going to happen because the data is consistent. Right. It's the same thing unless something changes, which, this year we had COVID. So a few things changed. All right. We changed a few things up and we, kind of, made our adjustments for that. And then, companies kind of slowed down on production. in operations, and people went home and that kind of thing. Okay. When you have forecasting, really, you're trying to make sure that you're trying to get the best forecast possible. But that's a lot of it boils down to sharing information, and making sure that there's no errors in the forecasting, because forecasting is very prone to errors because there's a lot of numbers in it, and people will sometimes just make admin errors in forecasting, or they'll go off a hunch or a feeling about something, which is in most cases probably not the best thing to do. Is to go off a feeling. Intuition is one thing, but in many cases, our intuition is very subjective because it's our intuition, right? I think this is going to happen, and that's what we call anecdotal. If you think it's going to happen, great, but you have the data to back it up, right? Show me the data. If the data doesn't support what you're saying, then it's going to be hard for me to go in that direction. So you don't necessarily want to always rely on anecdotal information. You want hard data, even if it's not a lot, but at least I have data that supports my, my theory, my hypothesis. Okay. And so if I have data that supports my hypothesis, then I can, with some certainty move forward with that particular hypothesis and say, well, that might happen, but let's see, what else can happen. But, I have an idea of what I can forecast, and then I can make adjustments based on that and say, well, this is, 30, 40%, 50%. The thing with forecasting is that you're never going to have all the answers, right? So sometimes you have 70% of the answer, sometimes you have 80%, sometimes you have 60%. You still got to make a decision, right? You still got to decide, right? We have to make a decision. And so based on that, we will try to find the best quality data we can, look at it from different perspectives, compare it to different things that we have, and then come up with our plan in which to make sure that our forecast is as close as possible to the demand, which again will translate into hopefully the sales, right? We're seeing in the sales, which reflect. And so that lets us know that our forecasting methods are working pretty well. The data that we're getting is good and high quality and consistent. All right. You have made it through today. All right, you survived. It's a little bit shorter than normal, but that's okay. We'll be all right. Okay. Any questions?
No.
No questions? Okay. So I will see you next week. Okay.
Okay. All right.
All right, David.
All right. Thank you.
You're welcome. All right.
And one of the reasons Netflix is so popular is because
You can go, Debbie. I'm just gonna wait for Moat. Moat. Moat.
Yes,
Moat.
doctor.
How you doing, sir?
Yeah, I'm fine, thank you.
No worries.
Yeah, I'm sorry I'm late today.
That's okay. That's all right. You tried. You showed up. So I literally just got done with the lecture. So I'm gonna post the video tomorrow, so you can watch
Yeah,
the
that's
video.
good.
But I will count you as good for attendance. Okay.
Yeah, okay. Thank
All
you.
right. You try to get in there. All right. You got any questions? Moat.
Yeah, no, doctor, thank you. Thank
Okay.
you so much.
All right.
But,
Okay. I'll see you next week.
yeah, thank you so much. Have a good day.
All right.
Thank you.